Hello and welcome to this short closeout video for the stakepool operator scripts convey error update. Let's start right with the GitHub repository. You can see that there was an update yesterday. Today is May 21, 2024, and the scripts have been all deployed in the testnet folder. So all the scripts with the lower numbers in the beginning are the normal ones, and all the new scripts beginning with the 2 are for the governance. And also, of course, the requirements for the governance and convey error have been updated. And when we take a look at the commits, there were quite a few of them starting way back around December, October, November. Here, first commits for Conway. We were in talks, I think, starting September, so I already started to implement stuff back then. So, yeah, they are deployed, and more information can then be found in the CloseOut report. I wanna split this video in 2 parts. First part will be to just show the basic functions, or just a few basic functions of the operator scripts, that they are now working normally in the convey error, and the second part will be focused on the new governance stuff. I'm currently connected here to 2 chains. The first chain is SanchoNet, and the second chain is a private network which will come into play later on. So let's start right here. Oh, and I forgot, you can see that both these networks are already in the convey error. So let's do just a few simple steps, and let's see if we have some funds. Yeah, we have an address here with 98,000 ADA, and yeah, we can send funds around. We can send it to ourselves. To consolidate these 2 UTXOs, we can use the command all. So let's do this transaction. Let's check out here above when a new block arrives. So there's a new block. So let's again check the funds, and they have been consolidated into only 1 UTXO. What else can we do? Let's create a new small wallet. Let's create one called new wallet, and we will do it on the CLI. So let's check if this is already on the chain. As you can see, it is not on the chain. Of course, we just created it. There's a base address and a stake key, so let's register them quickly. Okay, let's just wait a few seconds so that we see another block on SanchoNet. Okay, that took a little bit longer. So let's check back if it's now on chain. And yes, you can see the address is registered on in the chain with a deposit of 2 ADA, which is an important information already, because in convey error we can change this parameter via governance actions. So there were already changes to the certificate generation to include the current registration fee and to keep track of it. Okay, what else can we do? I think I have prepared a little test pool Let's see if this is on chain. No, it is not on chain. Okay. So let's register it just as a quick demonstration. And there's the owner in it. So we will delegate, see what the syntax is. It's the pool name. And the delegator, okay, looks good. And we register a new pool on the chain with some lovelaces from the wallet funds. Let's do a check. It's checking that the metadata is correctly uploaded. Yes, yes, yes. Collecting all the witnesses. Yes. Does it look good? Yes. Okay. And transaction has been submitted. Let's wait a few seconds so we can check again if the pool is on chain. And there's a new block. You can see here information for the DREP ID, also that the DREP IP is not on the chain currently. So scripts will continue to register them. We have not used an anchor URL, and we already have done this. So let's check if it's on chain. And you can see now the DREP is registered on the chain. So let's say we want to update this with an anchor information. Let's check the syntax. This is for the key generation and for the submit. We can simply use URL and hash. In online mode, as like right now, we don't need to provide a hash because the scripts will reach out to the URL destination and will automatically download that file and generate the hash. So let's run this command again, but this time let's attach a demo content, just a JSON file I'm hosting. So here we have an error warning. What does it say? That we have an issue here because it should start with https:// Also, you can see that IPFS URLs are also supported. Okay, let's scroll up a bit. You can see this line here. That's a new enter URL. That's the URL. This here is the hash. It checks again if the DREP is already registered on the chain. And yes, it knows it's registered with this deposit amount. The current enter is empty. And this will be now an update certificate. So there's no need to pay this deposit again. Let's say yes. Let's check it back on the chain. No update yet. So let me check this. Okay. So let's see if we had a block. Yeah, so there were a block. And now is the full information online. And I will now show and demonstrate this again using a hardware wallet. Okay, so let's bring this up here. And we will simply run script 21A again. Let's call this hardware DREP this time, and we want to do it with a hardware wallet. And let's make this even bigger. So I hope you can see this. And yeah, the hardware wallet is already active and is requesting this new derivation path for DREPs. Let's go and confirm this. Okay. Let's make this small again. Okay, so a new DREP key had been created, now called hardware DREP. So let's check if this is on chain just for confirmation. And of course, it's not registered on the chain. So let's do this. Also first check if we have some funds on the same hardware wallet. This is called Ledger Purple. In my case here, there are no funds. Let's send over some Lovelaces first. Let's send over 1000. Let's wait just quickly for a block on SunShinet. Okay. Let's just quickly check again. We have now 1000 Ether on the hardware wallet. Let's do the registration. Again, it's just the name. And the name of the wallet. So let's bring up the wallet again. Yes, we have a new transaction. You can see the protocol IDs, transaction fee. We want to register a DREP, of course. It's the key, the deposit amount. No entry was transferred. Yeah. The witness, we sign it. Okay, that's it. And let's submit this transaction. We need another block. Let me pause the video for a bit. There we go. So let's check again if this DREP is registered, and it is now on chain. So that was the new part for the DREP key generation for CLI wallets and also for hardware wallets. Of course, there's also a script called 21D, pretty similar to 21A. It's just to retire a DREP certificate on the chain. And it's also super simple. It's just the name and the payment address. We can do that quickly. The same hardware wallet. And it shows that we want to deregister a DREP certificate. And now the DREP key is deregistered again. Let's do a quick check. Yes, not registered anymore. Okay, so this concludes the part of the scripts for the DREP key generation and deregistration on chain. Next step is if you are holding a stake key and you want to delegate your voting power to an existing DREP. You can be your own DREP, so all you have to do is the things that I just showed, generate yourself a DREP key, and then you can delegate your staking power also to yourself. I think I have a stake address here called owner. Okay, nothing in there, no staking. Let's see if there are funds. No, but is it registered? Yes, it's just that. Okay. Let's see if we have an owner too. Not yet there. Okay. Then we just recreated a new wallet first. Okay, of course with no funds. So let's send some funds over so that this stake account also has some funds on the base address. Okay, so now let's say you are the owner of this wallet and you wanna delegate your voting power to the DREP called my DREP. Let's see how the syntax is. It's super simple. It's just the name, the local name. If you do it on the CLI, you can also use a DREP ID in hex code, or you can also use a DREP ID in back formation format. And yeah, so you will get this information from the social media or from online sites. So if someone is saying, "Hey, I'm a DREP and I want to represent this and that," yeah, you can use this DREP ID here. We want to use the local one, and we want to do this for the new wallet. The certificate has already been created. One thing to mention, you can also set your stake account to always abstain and always no confidence. So as always, the next step is to submit a certificate. Oh, that was the wrong one, sorry. So script with register the votes delegation certificate. What do we need? We need the stake address name. And we need a wallet with some funds on it. Let's do this for the new wallet. And some funds. Yes. Let's scroll up again. It tells you that it will delegate the voting power of the new wallet to the DREP with the hex ID here. And also the back format. One important step is that the script is also checking if this DREP you just used is really registered on the chain. Because there is no check on the chain itself. You could delegate to just a random hex code, but the scripts are reaching out to the chain and doing a query and checking that this DREP really exists on the chain. When we now do a check on the wallet itself, we can see that the address is of course registered. It's currently not delegated to any pool, but the voting power of the stake address is registered to this DREP. So that's a super and easy, simple way. If you have CLI keys or you have your key on your hardware wallet, to delegate your voting power to a DRAP. Let's jump to the next scripts. So the next ones are with the number 23. And the first one is a script to generate committee cold keys. And with the other ones, you can generate the keys in numerous ways. You can generate them just with CLI keys, encrypted, with a hardware wallet, and with mnemonics. So the difference is, let's create a key newcom CLI in the CLI mode. There you have it, your new committee cold keys. If you do this again with mnemonics, you can see that keys were again created, but this time derived from a special path and with these 24 words, which you could use also in the future and reuse it in a light wallet like Lace or Eternal. And what you can do, of course, is to generate a new committee cold key with the hardware wallet. Let's do this. Let's bring this window up again. And let's run this command. There we go. Your new committee cold keys derived from a hardware wallet. So there's a second script to this, like a sister or a brother script, and that's 23B. It's basically the same, but for the hotkeys. So you can generate also your committee hotkeys from CLI, encrypted CLI keys from the hardware wallet, or on the CLI with mnemonics, which you can later again use in a light wallet or a full node wallet. Okay, so for the next steps, I think I will jump over to the private chain because SunShiNet is currently in Conway Bootstrap phase, protocol version 9. And for the next steps, also to do some voting and some actions, we need the full governance protocol, protocol 10, and for this I have the private chain here. Let's just switch the chain quickly. That's it. Let me just quickly check if I have some funds here. Yes. Okay, and you can see that we are now on the private net. So on this private net, I have already a cold committee key in there. We can check the status of it with script 23D. It's called, mycom. And the script is checking the chain for the given committee key, which can be again a name if you just use it locally, or a hash. And you can see that this committee called key hash is on the chain. It's authorized by this hotkey. We'll come back to this in a second. The state of this committee member is active, is an authorized member. The expiration epoch is 168. And the action for the next epoch is that no change is expected. We can also do a quick demo if we want to try to authorize a cold key hash that has not been voted into the committee, and then you will see another action there for the next epoch change. Okay, so let's generate a new hotkey also on the hardware wallet to make it a little bit more difficult or exciting. And then we want to authorize this new hotkeys to be the key for this cold key hash here for the committee. Let's do this. Pretty simple. We generate a new hotkey. Let's call this hardware committee key. I hope I have not used this name before with the hardware wallet. Okay. And you can see this is from the path 5/0, the new one. Okay. We have generated this, this new hotkeys on the hardware wallet. We can also use this command 23D to check in on not only cold key hashes, but also hot ones. You can see it's checking the hot one now. And this hot one was not found on the chain yet. So let's authorize this hotkey to be the hotkey for the already registered committee cold key. Let's check the parameters we need. We need the name for the committee cold, the name for the committee hot, and a little wallet to pay for the funds. Let's scroll again up a bit. What can we see here? It's checking the information in the file for the my committee cold hash. It's checking the chain, that this committee key is really registered on the chain. You can see the current status again. Then here's the information for the new hotkey. And when we scroll up again to the first query, you could see that the old hotkey started with 5AA and ended with FC5. Let's check again. And as you can see, the hotkey has been swapped out. And this is now our new one that we just generated. What else can we do in this section? 23. We can, of course, retire a community key. The syntax is, again, super simple. It's just the name of the cold key file and the wallet to do this transaction. Let me check all the cold keys I am currently laying around. Here you have our keys that we generated first with the new community committee key in CLI hardware on mnemonics format. So let's try to authorize this new committee CLI key also with our newly generated hardware hotkey. That went through. Let's wait quickly before we have a new block. This network. Okay, new block arrived. And when we now checking in on our new hotkey, we can see that it is double on the chain now. It currently authorizes the already registered this committee cold key hash we had before. And the second entry here is that we tried to also authorize another cold key, and this new committee cold key was not voted in a committee yet. So the next epoch change will be that this authorization will be removed and that the cold hash key is unrecognized, and yeah, all this will be removed with the next epoch transition. So let's check the scripts again. So you can see this is already section 23. So 23 is all about committee keys. Okay. The next one is 24A and 24B. These are exciting ones because with these ones we can actually vote on an action. And let's jump a bit ahead and check if we have any actions yet on this private network. We can do so by running 24C. And we want to see all, we just see all. Okay, there are no matches found yet. So what we do is we jump back to SanchoNet. Okay, we are back on SanchoNet. So let's run this command again. And you can see there are a bunch of proposals, actions waiting to be voted on. As I said earlier, SanchoNet is currently in the bootstrap phase, so we are a bit limited in the kind of actions. But here is an interesting one, because that's the hard fork initiation that will allow SanchoNet to fork from protocol version 9 to 10. And let's say we wanna vote with our newly created test pool that we created, I think, 20 minutes before, on this proposal. You can see with this all tag here that it's just showing all the proposals that are on this chain. You can also filter this down to specific ones by just providing the action type. So that's one of these here. You can also, the scripts have all a bunch of examples in there. So you can filter, for example, only to see hard fork initiation proposals. Let's grab me this action ID again here, because you can, of course, also just show a specific action ID. And there are also other variants. You can query proposals based on a hash, which hash is involved for a pool or a committee, or which we can test later on. If you submit a proposal for yourself, or you know the stake address from another one, you can also check in the deposit return address, and it will only list then these proposals. Okay, but what we wanted to do was to vote on this specific action ID, which is the hard fork, to protocol version 10. So I've tried to break this down to make it really easy readable, what's really going on, because no one wants to read some JSON files. And yeah, you can here see for this proposal, and it's the same for all proposals, the submitted Encha URL with the corresponding hash. Then here you can see the address that will receive back the deposit amount, what kind of action it is, and the content of this action. If we want to vote for this, we simply call script 24a, and we want to do this now, let's say as drep committee. Let's do this as pool with our test pool for this specific action ID. So the script is listing again the action ID, what it is, so the same information that we just saw, the current votes, and then it's asking you for your vote, your decision. So let's say yes. Okay. The vote certificate was generated. As you can expect, we now have to register our vote. And that's again our drep name if we voted with as a drep, a committee out name if we voted with our committee, or our pool name. We just voted with our pool. And a little wallet to pay for this. And of course, let's scroll up. We need the vote file we generated. So let's run this. What you can see here now is that it's reading out and reading in this vote file again. It tells you that this vote file was generated to vote with a pool, the voter hash that was used, the action ID and the index again, and of course the answer we gave. So it was yes. This is just to double and triple check that you don't get a vote file from someone else or so that they said just submit that, so you can double check what's in there. Okay, let's submit this. Let's wait a bit before we see a new block on Sanchi node. We can check in on this proposal again. No new block and 11 stake pools voted so far. Let's wait for this new block. Okay. Let's run this command again. And you can see that now 12 pools have voted. So the last one was ours. It was that simple. So that's how easy it is to generate a drep, to delegate stake voting power to a drep, to generate committee keys, to authorize committee keys to do a vote on a specific action ID, and to check the current status of an action ID, or all of them are from a specific type. Also, when you submit such a vote, you can of course use all the extended features of the scripts, that you can attach a transaction message, and you can even encrypt this transaction message with the passphrase. And again, with many other scripts, when you, for example, you generate your vote that we just did, you can also extend this with an URL and a hash. In online mode, the hash will be calculated and checked automatically. So you can, show other users your, for example, your decision, why you have voted in this way. Okay, so this should conclude this part. And there is really only one big one left, and this is action generation and submit. And let's move back to the private chain. And let's do it on this chain because, we are really restricted on Sunshine right now because it's in bootstrap phase. And I want to show example for each action. So if we check again all the current proposals on chain, there is none. So let's create one. Broken down in a simple script called 25a, generate an action. What do we need? At least we need the name of a stake address, the action type itself, and we always need an anchor URL. Then we may or may not need additional parameters, so we can complete the action generation. Let me check. I should have a stake address here called owner. Yes, there it is. Let me check if there are also some funds on it. Yeah, there are 500,000K. And again, we have a wallet here with 9.4 million ADA. That should be enough. Okay, so let's generate a simple one, and the most simple one is just an info action. To do so, we call the script. We enter the deposit return address, the deposit return stake address. So this could be now a name or an address. We are using directly the name. Then we want to do an info action. And we want to use our test URL for this. And that's it. That's all we need to generate an info action. Already done. What information can we see here? It's an info action. The returning deposit stake address. That's our enter URL and the generated hash. We need currently, with this protocol parameter settings, an action deposit fee of 50K. And it said that it generated the action file without any issues. And there it is. That's the name of it. To submit this action file, we simply run script 25b. What do we need? We just need the name of our wallet and one or more action files. So let's copy the name of this action file and let's submit it on chain. Let's scroll up a bit. What can we see? We can see the content of this action file, that it is an info action, again the enter URL, the deposit value, and then deposit return address. Let's submit it. The action was submitted, and the last output of the script, it gave you your action ID. You can also submit multiple votes. We will do this in a minute at the same time, and then you will see multiple action IDs. So let's check the chain if there are new actions. And there it is. This is the action that we just generated and submitted on chain. Let's do another one. So next time is treasury withdrawals. An exciting one because we will get some money. So we can see down here below that we need in addition the amount of ADA or the amount of Lovelaces that we want to withdraw from the treasury. So we will use our owner again for the action deposit return. Let's use the old one. So we simply have to change this. Treasury withdrawals. So we need amount, and let's say we want 123,000 ADA. That's all parameters that we need so far. If we wanna have that the payout is going to another stake address, we can say so here by using like a context, a syntax like that. For this example, we are leaving this parameter out, so the action will generate it also to withdraw these Lovelaces to the stake address from the owner name. So let's run this. Here's the information again, and now the new part with the withdrawal amount and the stake address that will be used to withdraw them. Okay, here's the action file. We will not submit this right now. We will do it later on with a few at the same time. So let's generate another one. New constitution. What do we need for a new constitution? All the base parameters and at least an URL pointing to a file with the new constitution. So let's do this. We use the parameters from before. New constitution. Constitution URL. And I think I have a test file laying around here. If not, we will get an error. Okay, yeah, there was one. So what information do we see here now? It's a new constitution action. The URL of the file for the new constitution, it exists. And this is the hash that the action file was generated, and this is the name of the action file. So let's submit these two action files that we just generated. We can do this both at once. Just need a wallet. Let's scroll up a bit. So this was our treasury withdrawals action and our new constitution. Submit it. We scroll up a bit. So now you can see two entries here. The first one was our treasury withdrawals entry. And again, the scripts are listing all the information it can read out from this action, what's doing, so no one can fool you to submit an action that you don't know the content of. And the second one was our new constitution. You can here also see we don't have a constitution right now on the chain. So the referencing action ID of the last constitution is none. Okay, when we scroll down, oh, and let's check the deposit fees. So we have 50K for the first one, 50K for the second one, which result in a total deposit value of 100K. And after you've submitted the actions, you now get 2 action IDs. Let's see if they are already on chain, and there they are. So the first one was our info action. There's no additional information rather than the enter URL. Second one was the treasury withdrawals. Here we have an additional information about the withdrawal stake address and the withdrawal amount. The third one was the new constitution with the additional information of the new constitution URL and the hash. So we can submit a no confidence action. So let's reuse an old one here. We don't need another parameter. No confidence. Okay. And then let's do a parameter update, a parameter change. What do we need for a parameter change? We need a parameter from this list. But we can run the script with half the parameters, then we will get an error message and it will list the parameters again. So let's do this. Let's say we want to do a parameter change. Script is running and now it's complaining that it wants at least one parameter to update and to change. And the currently supported parameters are this whole list here. So let's pick one. Let's say we want to update the min pool cost to 100 ADA. Also, we want to update, let's see, the number of pools to 600. And then we want to update, I will delete this in a bit, but just to show you how this works, if we pick one from, let's say, this pool voting threshold. So let's set this to 17. What happens? Okay. First thing, it accepted these parameters that we input. It generated an error about the pool voting threshold committee no confidence parameter 17, because this should be irrational in the format 2/3 or 0. Just a regular decimal number. So let's say 3 out of 4. But there's an additional check. Because if you want to submit a parameter from this pool voting threshold group, you have to set all 5 of them. You can just submit one of them. That's just extra steps, and also, yeah, with all the numbers that you need, all the parameters. If I go back here, and let's say we want to set the number of pools to 120.5, then the script will complain that it can't accept this value of 120.5 because it should be a natural number greater than 0. No decimals allowed. Okay. So let's set it to 600 pools. Okay. This action was generated. And let's submit these last two ones. So we had this no confidence up there. Let me quickly find it. There we go. Also, as you can see, the files are named by the name of the local stake address, then the type, and the date and time. And we also pick this one here. Again, it lists the content of it. The first one is just a no confidence. There is no extra information. The only extra information that could be in there is a referencing action ID, but there is none. Same goes for this parameter change. If there was a parameter change before, the scripts will automatically check this on the chain and will set the reference action ID correctly. You can see that we have a parameter change here for the mean pool cost and for the stake pool target number to 600. Action have been submitted. We submitted 2 actions, so we also got back 2 action IDs that we can communicate via socials, so others can more easily find our action IDs and vote for it. So let's check the chain again about all the proposals. Okay, there are already 5 now. Number 4 is our no confidence, and number 5 is the parameter change. Again, you can see I've tried to make the information as simple as possible here. No one wants to read JSON files, so it really points out what's going on and that we want to change this to parameter, so this parameter to this value. Okay. What's the next one? The next one is to update committee members. What do we need in additional information for this? You can find this here. We need, of course, a new or an old threshold value. So the threshold is a required parameter. But then we can add key hashes or script hashes, or we can remove key hashes or script hashes. Then we can set a max term epoch. If we don't set this, the max term length will be automatically chosen. So let's see. What old key hashes do we have currently? The one that we generated before, of course. So let's say we want to make an action that our newly created committee member will get into the committee. So we will need this hash. Let's use an old one here so we don't have to retype this all again. So this is now an update committee action. First, we want to set the new threshold to, let's say, 4 out of 7 members must vote or must find a quorum. And then we want to add a member with this hash. To show the output a bit better, let's say we want to remove a hash. And let's just make one up with this 3 zeros at the end. Okay. So what do we see now here again? The action deposit fee of 50K. and then here are all the used parameters. We did not specify a max time epoch, so it's automatically calculated the maximum possible value, which is 142. The new threshold will be set to 4/7. We want to add this cold key hash ending with 999, and we want to remove this cold key hash ending with 000. So let's submit this on the chain. We have to use 25B, of course. Okay, let's scroll up. You can see all the base information in here. Also the new threshold. And it also shows that this 4/7 is 57%. Whoop, let's scroll up again. Then we can see that we wanna add this key hash. And it also shows that the max time epoch for this key hash will be 142. And we wanna remove this key hash. Let's submit it. Let me open this up again to see when we have a new block. There it is. If we now check all proposals again on the chain, there we have it. It's the 6 ones. And you can see all the relevant information again here. We knew it already because we submitted it, but if this proposal is coming from someone else, you can see a threshold. You can see the cold committee key hash they want to add and the max time epoch, and you can see the key hash they want to remove. If you do this with the script hash, it will just say script hash here, and you can add and remove as many as you like in one transaction. So there is one last one that we have to do, and that's a hard fork. Let's do this. What do we need for a hard fork? For a hard fork, we just need the version number that we want to fork to. This private net is now forked to protocol version 10.0. So let's type this out pretty quickly. We want to do a hard fork. Again, we need a URL. And the version we want to fork to. So we are on 10.0. Let's fork to 10.2. Okay, that worked. You can see the information, fork to protocol version 10.2. If we say we want to fork to 11.3, then there's a check. Because if we increase the major protocol version number, the minor number must be 0. So it must be 11.0 in that case. That also worked. If we go way far ahead and we want to fork to protocol version 12, it will tell you that you can only increase the protocol version, the major one, by 1. So you can't jump protocol major versions. But let's pick our first one with the fork to protocol version 10.2. This was this action file. Let us submit this quickly. This time we also attach a message. Yeah, let's fork to the new protocol version. Okay. We didn't like because we can't, we are not allowed to do so. Okay, I just retried quickly with 10.1. Looks like we can't jump from 10.0 to 10.2. That might be a bug in the node, or it might actually be correct. Never mind. I just submitted an action again to fork to 10.1. Finally, let's see if this is already on chain. It's not. Let's wait a bit before I get a new block here. New block arrived. Let's check again. And the last one is our fork to 10.1. Okay, yeah, I think that completes yeah, this closeout video. I just showed a little bit of the functions that you can do with the scripts. You can do much more. You can add way more information to the transactions. But yeah, we've gone through all the new stuff, DREP keys and delegation and committee cold keys and hotkeys on the CLI, on hardware wallets. Yeah, you can, of course, generate and submit a vote on the hardware wallet. I didn't show that because we are already over 1 hour. And I'm sorry that this video is that long. But I just wanted to show you all the new fun Conway and governance stuff. Okay, thank you very much.